I didn't use a table for this one because it was just shifted right pi over 4 and down 2. So whatever your asymptotes were, so they were at all of your multiples of pi, 0, pi, 2 pi, all of those. They are now shifted right pi over 4, so instead of 0, it's pi over 4. Instead of negative pi, it's negative 3 pi over 4, and that pattern continues. And then whatever the graph was is now been shifted down 2, so to negative 1 and negative 3. The y-intercept, you have to put 0 in for x. You get cosecant of negative pi over 4, which is negative root 2, and then minus 2. So that's how we got that one, if you were curious. I'm not sure if I said this here or in first, but I just am correcting it in both. When we were talking about the asymptotes in these two, I think I said something about taking just these and adding the period, but that wasn't entirely true because there's multiple asymptotes in a period. So it should really be half of the period. So for 25, it should have been really 3 pi over 8, not 3 pi over 4 at the end. And 26 was pi over 3, not 2 pi over 3. So half of whatever the actual period is for your asymptotes and the domain restriction. Questions on 24? I did use a table because that one stretched a lot, but only the final table is up there. So because it's stretched so much, it's not actually graphed here that we can see. This is supposed to show that it's so far off the graph. None of these points show you that it's actually on the graph, so you have to find the patterns. Here we see every 4 pi would have been an asymptote. So starting at negative 2 pi, count 4 pi, and you get another asymptote. And then this point right here is supposed to represent that, but you can't really see it. So this example, you really just graphed your asymptotes, not really anything else. Had we had a bigger graph, we could have seen our x-intercepts, because it would eventually gone to your x-axis. Questions on that one? Yeah.
How should you get a period 8 pi?
So if we have 2 pi over 1/4, because that's the number in front of x, you would multiply by the reciprocal to get that 8 pi. And think about this piece right here is only one section of it. It has to do the other part. So it hasn't actually repeated itself. Other questions on this one? Last graph we have to talk about is cotangent. So cotangent's characteristics are very much similar to tangent, except a little different. Remember that cotangent is the reciprocal, so we have to remember what that means. Wherever tangent had asymptotes, cotangent will not have asymptotes. Wherever tangent was 0, cotangent will now have asymptotes. So this table is going to be a little different. Now we're going to start at 0 and then go up to pi because the period will not change. It's still a period of pi. And then refer back to what tangent was, and cotangent will be the opposite, or if it was 1, the same number. Bless you. So what would the cotangent of 0 be? be undefined, which would mean cotangent of pi is also undefined. Cotangent of pi over 4. 1. Cotangent of pi over 2. 0. And then cotangent of 3 pi over 4. Negative. So our asymptotes are now going to be at every multiple of pi. And it still repeats itself, it's still periodic. So between 0 and pi, pi over 4 goes up to 1, pi over 2 is at 0, and 3 pi over 4 is at negative 1. So now instead of going up to the right, it's going up to the left. Yes.
How are you finding your asymptote?
These two. And then it repeats itself. So every point in the middle would fall on your x-axis for your parent function. And then to the left, it would go up 1. And to the right, it would go down 1. This should be this one. So it kind of looks like tangent, but basically it's been shifted and flipped. Just like tangent, amplitude, and midline are none. Oh, she's not. Midline doesn't have the box, but it would be none. Period is still pi, so you're still using pi over b to find it. Domain is wherever your asymptotes are. It's not where your asymptotes are. So x equals pi over pi k, sorry. Every multiple of pi.
Isn't it x can't equal pi k?
Yes, sorry. Your range is what? It's not undefined for your range. It's all real numbers. So your range for tangent and cotangent are the same. Your range for sine and cosine are the same. I'm sorry, domain, cosine and cosine are the same. Here, our x-intercepts fall on all of our multiples of pi over 2. So pi over 2 plus pi k. Every odd multiple of pi over 2. In this case, we don't have a y-intercept because of our asymptotes. And then x equals pi k are our asymptotes.
Does your domain say x doesn't equal pi what?
Pi k. Alright, so we're going to do one of these examples together, and I'm going to let you do the other one. Let's do 29. So notice that this has a number before x. So we need to factor that number out. Remember, when you're factoring that number out, you're really dividing. So what is our new number on the inside? Yes. So minus 4 pi. So now our phase shift is what? Should be right 4 pi. Our vertical shift? Up 4. 28, you may be able to do without tables. 29, I did tables because of the stretch to see where it was. going to use the table we just found for the parent function. So 0, pi over 4, pi over 2, 3 pi over 4, pi, bless you, for your x's. And then undefined, 1, 0, negative 1, undefined for your y's. What are we multiplying our x's by? 2, because it's the reciprocal, and then your y's by negative 1/2. So your x's become 0, pi over 2, pi, 3 pi over 2, 6 pi over 4, reduced, and 2 pi. And then your y's, remember anything undefined stays undefined. Negative 1/2, 0, 1/2. And then we are adding 4 pi to our x's and adding 4 to our y's. Right? Because there's a lot of fractions, you can either add the fractions. I'm thinking about them as decimals when I'm adding them to make it a little bit easier. So 4 pi plus, or 4 plus 1/2 is 4 1/2, or 9/2. 5 pi, 4 pi plus 1.5 is 5.5, so 11/2, and then 6 pi. And then same thing for your y's. I'm adding 4, so 3 1/2, 4, and then 4 1/2, or 9/2. None of these points actually help me graph anything because none of these fall in my space of my graph. But what I can see are patterns. I see that every 2 pi there's going to be an asymptote. So if I go back 2 pi, I would be at 2 pi and there would be an asymptote. If I go back 2 pi more, there'd be another asymptote. Go back 2 pi more and there'd be another asymptote. And then I know I'm going to repeat these 3, but I need to go backwards because it's at 4 and 6. So if I'm going backwards, I want this asymptote to be 0 and this asymptote to be 2 pi. That means if I'm counting by halves, if this was 0, this would be pi over 2, or 1/2. So at pi over 2, it would be 3.5. That would be 1, or pi. So at pi, it would be 4. 1 1/2, or 3 pi over 2 would be 4.5. And then 2 pi. And then it would repeat itself again for this one. So dead in the center would be at 4. 2 to the right would be up 1/2. 2 to the left would be down 1/2. For this one, because it was reflected, it now looks like a tangent graph instead of a cotangent graph. Sometimes that will happen. Just like when you reflect sine or secant and cosecant, they will look like each other. Questions on the actual graph piece? Amplitude and midline is none. R none. What would your period be? 2 pi. It's going to repeat itself every 2 pi, and you kind of see that. I'm going to write our asymptotes, then we'll write our domain. So our asymptotes are at every 2 pi, x equals 2 pi k. So domain is not that. Range is still all real numbers. Our x-intercepts are going to be something between 0 and pi over 4. So don't worry about that. And then in this case, we wouldn't have a y-intercept because of our asymptotes. Questions on any of those? I want you to go ahead and try the other one. And then there is one thing that I saw on, we'll talk about it, and then there's one thing on the study guide that I wanted to talk to you about. And then we'll talk about how we're going to do testing. So for 28, you should have had asymptotes at every pi over 2, so all of your zeros and pi's, all of your pi's over 2. And then it's moving right through pi over 2 and then down 3. So somewhere in the middle of these, you should be at -3 and then go left, up 1, left 1, and down 1, right 1. Yes?
Why is it period of pi over 2?
Because it's pi over b and 2 is your b. So if you were doing your tables, even though you multiplied all of your x's by 1/2 and you added all of them by 3 pi over 2, you still ended up at 3 pi over 2 and 2 pi. So it would have repeated itself every each of those for your asymptotes. Questions on that one? So on the study guide, I noticed this. Back when we were doing solving right triangles and we'd find the side, we didn't do any examples like this, and I just wanted to make sure that we were all on the same page. Now, it's not a new concept, but just so that you know it and have it and can't say that I didn't show it for you. So anytime you're not given an angle, well, one, you're still going to do the same process. You're still thinking SOHCAHTOA in your head. But you're now looking for this angle. So this is actually on the Unit 4 study guide. I think there's one on the quarter test study guide that on Edmodo I told you to change it to this. So anytime you get a problem like this, where they do not give you the angle, think about, how could I find this angle? Well, I still have adjacent, I still have hypotenuse, so that's still using cosine. But since you're looking for the angle, you have to take the inverse. So whatever fraction you get, you're going to take the inverse of that. So that is right above your sine, cosine, and tangent in blue. So you would take the inverse of whatever that fraction was, and that's about 24 over 37. Except when you do this, your calculator needs to be in degrees. So any question that is asking you to solve for right triangles, but is asking you to find the angle, you're doing the inverse. You're not doing cosine of 24 over 37. And anytime it's asking you to find the angle, you're doing cosine inverse of that fraction, not cosine of that fraction. Cosine of some angle of that fraction. Because usually when you solve these, you have some angles. Like these two, you were given some angle. So you could do sine of 22 equals and set it up. Tangent of 64 equals and set it up. But that was different. This is also on Edmodo, has been. Okay. Questions on that? Yes.
Extras of that.
Maybe. In the teal crate, I don't think this unit is labeled, but it's a tiny unit. Now, to talk about testing. So, we are testing on Friday for Unit 4, but that leaves us Wednesday and Friday, so those dates are wrong, because I forgot that we don't have school Monday, and I messed this up. So Wednesday and Friday is the next time I see you guys next week, which means that doesn't give us time to really review for the quarter tests. So we can do that today, and then go ahead and test Tuesday, or we can review for Wednesday. Review for part of Wednesday, but that takes away from your test time. So I'm going to let you guys choose. Do you want to review today or review on Wednesday?
Wednesday.
That means if you don't finish Wednesday and Friday, or I'd say this, come see me Thursday and work on it after school. That way you have the time in class on Friday. Yes.
So we'll be able to come after school Wednesday as well.
No. So you'd be able to come in Thursday. You could come in early to take it Tuesday, or come see me in the morning. But unless you're absent for some reason on both days, I'm not having anyone come see me Monday. So you have to get it done within those 2 days. That also means we're not reviewing the entire packet on Wednesday, because you have to have some time to test. Okay. You guys chose. But if you have specific questions, you can come up to me on either study guide. Both answer keys are on Edmodo, but for the rest of the class, you have this time to study, practice, ask questions.